In this video, I'm going to talk about standard deviation and variance. Now, both these standard deviation and variance specify the spread of data, but with respect to mean. They are always mentioned with mean. Let's see how to calculate them. So, I have taken values from 1 to 6. Now, I will calculate mean, which turns out to be 3.5. Okay. Following that, I will subtract each individual value from the mean. And if I sum these subtracted values, they will add up to 0. So there is no use to sum up these values or take the mean out of them. Therefore, we take the square of these subtracted values and then add them up so that we can take mean of those values. So what we will do is take the mean of the values by summing them up and dividing them with the number of values. This will give me variance. And if I take the square root of the variance, then it will give me standard deviation. So variance will be square of the average distance of data from mean, whereas standard deviation will be average distance of data from mean. Here we are taking a square root because previously we have squared the values. So since variance is square of values, so that's why its units are different than mean. They are always squared out. So that's why whenever we mention mean, we mention standard deviation along with it and not variance. But variance is also useful in many cases, for example, to compare different data sets. That I will talk about in later videos. Let's tackle out the formula for standard deviation and variance. Now suppose I say each value is x and I can denote them with x, then I can represent mean by x with a bar. Then I can say that mean minus value will be x bar minus x, and the square of these will be the square of x bar minus x. Then I will sum up the values. So let's add a summation sign with square of x bar minus x and then division with the number of values, that is n. This will be variance and its square root will be standard deviation. But usually we don't take n. Instead we take n minus 1. To explain this, let's first talk about population and sample. Now suppose I want to calculate average scores of students in a school. But the school has approximately 10,000 students, let's say. So it will be very laborious and tedious to count so many scores. What if instead I take a class of 50 students only and calculate the scores? So my population will become all the students in the school and the sample will become the 50 students of a class. This taking the sample out of a population is a very commonplace occurrence in statistics because many a times we cannot take the whole population. Sometimes it's difficult and sometimes it's near impossible. If I start taking the whole population of the world, then it will be really difficult to estimate the data from there. For example, if in this case also, if instead of scores of a school, I want to know scores of an area or maybe a city or a country or a continent or the whole world, then how I'm going to do this? That's why taking sample of small sample instead of a population, whole population, it's more common. Now, if we take population data for calculation, then the result will be the actual answers. The actual results will be given. Whereas for sample data, whatever results we get, means as standard deviation, variance, they will be representative of the population. But you cannot say that these are the exact results that we will get from the population. For example, population mean is 72. But depending how each class has performed, in a previous example, some classes will have a average score of 50 or some will have 90. Maybe one class would also have the mean of 72. But that's not always the case. That's why population and sample statistics are denoted by different letters. Like mean of the population will be denoted by mu, and for sample it will be x bar. Similarly, standard deviation for population will be sigma and it will be s for sample. And when we will calculate the standard deviation, it will have n for population and n minus 1 for sample. That I will explain later. Here also for population the n will be capital and for sample the n will be small. Here also variance will be square of the standard deviation. So for population variance will be sigma square and for sample it will be s square. So generally what happens that if we increase the sample size, if we take in more and more values to calculate mean and standard deviation, etc., then standard deviation and variance will go down. That is the normal scenario that happens. So it means that the standard deviation of the population should always be less than the sample, because sample size would always be less than the population size. But if we use n for calculation of standard deviation for both population and sample, then standard deviation of the population will turn out to be greater than sample. There is a whole calculation for this, but I am not delving deeper into this. Okay, so that's why instead of using n, we use n minus 1 for calculation of standard deviation of sample. Now, additionally, I want to talk about standard error of mean. Now, suppose instead of one class, I am taking 10 classes to calculate the average score. Okay, so I am taking 10 classes, it will mean I will have 10 means for 10 different classes. Now, standard deviation of those 10 means, I am talking about means and not the observations. For those 10 means is termed as standard error of mean. That means standard deviation of the means that we have accumulated. It can be calculated by dividing standard deviation with square root of n. Thank you for watching. Please like, share and subscribe if you like the video.